All right, let's look at the theorem 2, SSA theorem. All right, notice that this is not a congruence criterion. Right, so it says that we have SSA, so you have a AC side and a side angle. Right, this is not quite enough to conclude the establish the congruence, but if they are not congruent, the third angle here, so it's not the angle between those two sides or the angle that are congruent. So angle C and angle Z are supplementary, which means that the sum of their measures is going to be 180. Right, so let's prove that. Alright, so I wrote that the givens AC equals XZ, AB equals XY, and angle B is congruent to angle Y, and then these are not congruent, so these guys are not congruent to each other. Alright, so what we can do is 5, so since we know that they are not congruent, we know that if you compare BC and XZ, they must be different, because otherwise we can use a side angle side to establish congruence. So we know that BC is not equal to YZ. Right? So this is by side angle psi, because side angle psi would establish the congruence otherwise. Alright, then so if they're not the same, so one has to be longer, so I'll just say, alright, I'm going to assume that BC is longer than YZ. Right, so this is the without loss of generality, because one has to be larger, so we're going to assume BC is going to be longer. Right, so since BC is longer, we can always construct say C prime, so maybe around here, so C prime, so that the length here matches, maybe I'll do matches this guy right here. Alright, so I'm going to just draw a triangle. Alright, so I'm going to say 7. I'm going to construct point C prime between B and C, such that BC prime is equal to YZ. Right, so this is just a segment construction theorem, so I'll just say construction theorem will justify that step. And then we know that if you look at this triangle here, ABC prime and XYZ, they are congruent. So triangle ABC prime is congruent to triangle XYZ. Right, and this is by side angle side. So side is let's see, we have AB, so it's a line 2. Angle comes from line 3, and then you have BC prime equal to Y, so it comes from number 7. Right, so we have that. Then we have this. We have a congruence between these two angles. So this angle right here would be congruent to that angle right there. Right? So I'm going to just write down 9. Right? So we have, let's see, angle AC prime B is congruent to angle Z. Alright, so this is just the corresponding parts of congruent figures. And then we also have these guys. This angle is going to be congruent to that angle because, well, actually, we have to establish that. So before we say that, we have to show that right, AC corresponds to XZ, right? So AC prime, I should say, corresponds to XZ. I remember that the XZ is congruent to AC. So this is by, again, corresponding parts of congruent figures. Right, and also I combined the let's see, AC, so number 1. All right, so we know that this is actually an isosceles triangle right here. So we have an isosceles triangle. So we can say number 11, angle AC prime C is congruent to angle C. So this is isosceles triangle theorem. Alright, then we can say, so we know that number 12, we know that the measure of the angle AC prime B plus measure of the angle AC prime C is equal to 180, right? Because they're linear pair, so I'll just say linear pair. All right, but so AC prime B is congruent to angle Z, so we have, I think we have the conclusion. So therefore, alright, so this guy is congruent to angle Z, so you have, I'm going to write it here, measure of the angle Z plus, right, AC prime C is congruent to angle C, so measure of the angle C, the sum is equal to 180, right? So I'm combining, let's see, I've used the number 9 and also number 11 and 12 to make that conclusion. All right, so the third angle, if you have SSA and if the triangles are not congruent, then the third angle, a corresponding third angle, are supplementary, which means that the sum of the measures is equal to 180. All right, that's it. I hope that this was clear.